Welcome to the DIY Honda Garage channel. The diagnostic trouble code P0777 specifically relates to the CVT, continuously variable transmission, driven pulley pressure control solenoid valve being stuck in the on position. This component plays a crucial role in regulating the hydraulic pressure to the driven pulley, essential for the smooth operation of the vehicle's drivetrain. Located within the transmission, CVT-driven pulley pressure control solenoid is electronically monitored and controlled by the Powertrain Control Module, PCM. When the transmission encounters certain conditions, such as the forward clutch engaging while the vehicle is stationary, an excessive or improper hydraulic pressure signal prompts the PCM to log this error code. The malfunction typically indicates that the solenoid valve is not functioning correctly, potentially leading to issues like belt slippage during driving or an improper pulley ratio. Understanding this code is vital for accurate troubleshooting and ensuring the vehicle operates as intended. The final step in the troubleshooting process is to repeat the driving pattern previously established. This repetition is vital to confirm whether the symptoms recur and if DTC P0777 persists under the same operating conditions. Consistency in the driving procedure may highlight any intermittent issues with the CVT system, whereby the solenoid valve may function correctly in some scenarios but fail in others. Observing and recording the behavior of the powertrain, solenoid responses, and any corresponding diagnostic messages during this repeat trip is necessary for drawing valuable conclusions regarding the state of the vehicle's transmission. Such a systematic approach ultimately aids in pinpointing root causes more effectively while ensuring that all aspects of performance are closely monitored. After completing the necessary repairs on components linked to DTC P0777, the next step involves clearing the diagnostic trouble codes from the vehicle's PCM. This is typically accomplished through the use of a specialized OBD-II scan tool, which allows for the deletion of stored DTCs and provides a clean slate for monitoring future vehicle performance. Following the clearing process, verifying the operation of the CVT system is essential to confirm that the repairs have fully resolved the underlying issues. The technician should conduct a test drive similar to previous evaluation steps, ensuring that no warning lights illuminate and that the vehicle operates smoothly under various conditions. The success of these actions would indicate that the critical solenoid valve is functioning correctly and that the DTC will not return, affirming the integrity of the repair made. To help prevent the occurrence of DTC P0777 in the future, establishing a routine preventive maintenance schedule is essential. Regularly changing the transmission fluid can significantly impact the health and performance of the CVT system. Clean fluid reduces contamination that may obstruct the solenoid's operation. Additionally, routine inspections of related components, especially the CVT-driven pulley pressure control solenoid, can assist in early identification of wear or malfunctions. Ensuring all electrical connections are clean, secure, and not prone to corrosion further enhances longevity. Being proactive in these maintenance practices helps preserve the efficient operation of the transmission system, potentially reducing the likelihood of DTCs developing in the future. In summary, DTC P0777 serves as an important indicator of potential issues with the CVT-driven pulley pressure control solenoid valve. Early identification of symptoms, such as belt slippage or unexpected stalling, is crucial for effective resolution. Adopting a thorough approach to diagnostics, including proper testing protocols, can lead to accurate findings and repairs. Importantly, integrating regular maintenance practices into vehicle care can notably reduce the risk of such trouble codes from emerging. Keeping in mind the intricate relationship between the components and their operational demands will aid technicians in providing optimal service for Honda Accord models between 2012 and 2017. The CVT-driven pulley pressure control solenoid valve is integral to maintaining the correct hydraulic pressure for the driven pulley, which allows for seamless transmission shifts. It operates based on duty cycle outputs sent from the PCM, adjusting the internal spool to regulate hydraulic pressure levels accordingly. When the system functions correctly, the valve opens and closes to modulate how much pressure the driven pulley receives. However, if the valve becomes stuck on, it leads to hydraulic pressure being continuously applied, which can result in trouble such as unintended belt slippage or wrong pulley ratios. This error primarily emerges when the transmission is in a specific transition phase, and the PCM detects that the conditions causing the overdrive situation are present while the vehicle is stopped. Thus, understanding where this component is located and its function enhances the diagnostic and repair process for this DTC. The root causes of DTC P0777 can vary, but typically start with the CVT-driven pulley pressure control solenoid valve itself being stuck in the activated position. This can be due to wear and tear, electrical failures, or contaminants affecting its operation. Another possibility includes faults within the PCM that inaccurately interpret the solenoid status or mismanage the hydraulic pressure control signal. Additionally, wiring issues, such as frayed or corroded connection points between the solenoid and the PCM, can impede proper function. It's crucial to recognize that the listed causes may not be exhaustive. Other underlying mechanical faults or sensor malfunctions could also contribute to this DTC. Comprehensive diagnostics are essential to identify the precise failure point. Identifying the symptoms associated with DTC P0777 is key to timely diagnosis. One common manifestation is vehicle stalling or difficulty in maintaining speed, which might occur when the hydraulic pressure is improperly managed. Additionally, drivers may notice belt slippage during driving, pronounced particularly under acceleration or load, as the driven pulley cannot engage effectively. Moreover, the malfunction indicator lamp, or MIL, usually illuminates when the error is present, providing a visual cue that further diagnostics are required. The AT gear position indicator may also blink, indicating transmission-related issues. Understanding these symptoms can guide a technician in recognizing when this specific trouble code is likely at play, facilitating quicker and more accurate repairs. The first step in troubleshooting DTC P0777 involves starting the engine to establish a baseline. This allows the technician to not only check for the presence of DTCs, but also observe the vehicle's behavior under current running conditions. The engine must be allowed to reach its operational state, ensuring the onboard diagnostic system can effectively monitor all parameters. Once started, the technician will typically use an OBD-II scan tool to read any active codes, including DTC P0777, and note if there are any additional codes related to the transmission or solenoid function that may provide further insight. Early verification of DTCs sets the stage for a targeted diagnostic approach, allowing for efficient identification of issues. To further diagnose the concern highlighted by DTC P0777, the next critical step involves accelerating the vehicle in the drive or D gear until reaching 38 miles per hour, 60 kilometers per hour. This action engages the transmission's normal operations under load, essential for generating the required signals that indicate the solenoid's behavior during operation. Monitoring the vehicle at this speed helps to assess how effectively the hydraulic pressure is managed by the CVT system. It is recommended to ensure all traffic regulations and ambient conditions are met during this step, as safety is paramount. This phase allows for initial real-time feedback from the transmission components and sets up the situation for further monitoring of any unusual occurrences. Following the acceleration phase, the technician must slow down and come to a complete stop. This step is critical as it places the vehicle under conditions that may initiate the solenoid valve's dysfunction, particularly in relation to the CVT-driven pulley function. It's during this idle state, with the forward clutch engaged, that any potential issue in the control solenoid can manifest, showing if the hydraulic pressure is incorrectly sustained. Observing for signs of an incorrect pulley ratio or abnormal pressure readings at this point helps to clarify the valve's operational condition. Should the symptoms align with the expectations established by DTC P0777, it leads to further diagnostic focus on the solenoid and its control parameters. The next step in the diagnostic sequence involves accelerating the vehicle with wide open throttle. This action tests the responsiveness of the powertrain under maximum load, providing insight into how well the CVT system adapts to dynamic changes in throttle input. During this acceleration phase, the technician should closely monitor for any deviations in the vehicle's performance, particularly signs of belt slippage or unexpected changes in engine RPM relative to vehicle speed. Any anomalies may indicate that the CVT-driven pulley pressure control solenoid valve is compromised, further supporting the diagnosis tied to DTC P0777. This step is essential to ascertain whether the system can maintain adequate hydraulic control when subjected to aggressive driving conditions. After completing the acceleration test, it is essential to stop the vehicle and turn off the ignition switch, bringing the engine to a halt. This serves multiple purposes, such as allowing the technician to check for any diagnostic retrieval from the vehicle's onboard system and resetting the vehicle's operational state. At this point, important data may be stored in the PCM regarding the recent drive cycles, ensuring that the technician can later analyze performance trends or recurrent faults. Preparing to repeat the previously mentioned driving pattern ensures robust data collection for a more thorough examination of the solenoid's performance during varied operating conditions. This reflective phased approach is critical for identifying intermittent, elusive faults that may not appear during a single test. Please like and subscribe to the channel. See you next time.